Hello, my name is Milan Cermak, and in this short presentation I would like to summarize you the initial results of our research focused on the utilization of graph database for network forensics. You might be wondering, why do we even consider using graph databases for network forensics? The reason is that analysis of network data is typically performed by tools allowing manual browsing, filtering, and aggregation, or tools based on statistical analysis and visualizations facilitating data comprehension. However, the human brain is used to perceive the data in associations, which these tools can provide only in a limited form. On the other hand, graph databases allow us to perceive network data in such a way. In this presentation, I will present our initial results, describe data transformation principles, utilization of scalable graph database, and introduce you some analysis techniques. To evaluate and demonstrate possibilities of association-based network traffic analysis, we introduce a GRANEF toolkit. The core of the toolkit is a graph database dgraph capable to efficiently store and analyze large amounts of data, which is difficult to achieve in the well-known Neo4j database. The graph database stores logs from the Zeek network security monitor, which is widely used in network forensics and allow us to extract all relevant information from captured network traffic. The transformation of these logs into graph database format is handled by our custom script, which transforms the logs according to the scheme that I will describe in more detail on the next slide. The data processing and analysis tools are implemented as standalone modules in Docker containers. Such a separation allows us to easily replace or update some modules without changing the remaining. Besides, this approach allows us to store intermediate results and use them in other analytical tools or speed up the data processing for a new analysis. One of the most challenging tasks of the utilization of the graph database for network forensics was to define an appropriate database schema that will capture all relevant information and won't lead to a large number of nodes overwhelming the database. Our scheme is based on the ones proposed by Denisa and Leichnam, who represent individual logs as separate nodes and connect them with defined associations. Compared to previously proposed schemas, we add an additional edge communicated between individual hosts to facilitate the definition of queries focused only on the connection existence. We also simplify edge naming to be uniform through all logs and make it easier to query the entire schema. The resulting schema is designed to reflect people's common perception of how a computer network works and simplifies the analysis. Thanks to the universal definition of the schema, it is possible to transform other types of data related to network traffic analysis in a similar way as using the Zeek. An example are system logs or IP flows extended by application data. Data stored in the dgraph database are queried using Draph Query Language, which is based on GraphQL. On the slide, you can see an example of a query that selects TCP connections and checks for transferred files from a local network. The Draph Query Language is quite powerful. However, a disadvantage is that it's not widespread and the analyst must devote some time to perform advanced queries. To overcome this issue, we have created an additional analysis module providing an abstract layer over the Draph Query Language. Therefore, an analyst can define custom query or use some predefined functions focused on network data analysis. Results of the query are provided either as a JSON, which is useful for further processing, or shown in an interactive relationship diagram. This visualization makes it easy to browse nodes, filter or group them, and provide functions which follow up analytical queries. The advantage is that the analyst has access to the base data while also having general overview available. As I mentioned before, the main part of the toolkit is exploratory analysis that allows the analyst to browse data in a new way that follows human thinking and perception of the surrounding world. An example of such analysis is in the video you see here on the slide. Currently, we are only using basic form of visualization and API functions. However, we are preparing a complex environment where exploratory analysis will play a major role. The typical analysis starts with a restriction of nodes we want to focus on. To do so, we need to understand the nature of as many hosts and connections as possible to distinguish unusual network traffics. Examples of some queries are return all connections and protocol types between two specific hosts, or return a number of all specified connection for hosts that fall within given IP range. The results of the query that focus on subset of ongoing TCP connection of one host can be seen in the figure on the right. An advantage of such visualization is that it often allows the analyst to distinguish regular network traffic from suspicious one just at a first glance based solely on the resulting pattern. In the provided example, it will be relevant to pay attention to the communication with the left node. Although we are at the beginning of our research, the current results show the great potential of association-based analysis. Graph-based network forensics is a new approach to analyze network traffic data utilizing modern database technologies capable of storing large amounts of information based on their association. It follows the typical way of human thinking and perception of the characteristics of the surrounding world. Its main advantage is the connection of exploratory analysis of network traffic data with results visualization, allowing the analyst to easily go through the acquired knowledge and visually identify interesting network traffic. Our experience also shows that this approach is not only the new method of data storage and querying, but it also leads to a shift of mindset that allows us to perceive network data in a new way. We are currently finalizing the initial version of the graphical analysis environment, so the toolkit is not publicly available now. However, if you are interested, just send me an email and I will be happy to provide it to you. So, thank you for your attention, and if you have any questions, feel free to ask.